So today we are going to talk about centripetal force and centripetal acceleration. Centripetal force and centripetal acceleration are applicable to any object traveling in a circular path. In other words, this strategy in this video, you can always use this if something is traveling in a circle. However, you don't have to use this. This video is going to cover three major ideas. Number 1, to find the centripetal force. Number 2, to find the speed and the acceleration of an object traveling in a circle at a constant speed. And number 3, to determine the period of circular motion. Let's talk about some definitions. Centripetal force, the net force that must act on an object to keep it in a circular path. Centripetal acceleration is the acceleration that an object must have in order to stay in a circular path. And period of circular motion is the time necessary for an object to complete one revolution around the circle, also known as a cycle. To determine the magnitude of the centripetal force, use the formula sum of all the forces equals mv squared over r. M stands for the mass, and that is in the units of kilograms. V is the velocity, and that is the units of meters per second. And r is the radius, which is in the units of meters. Force has the units of N, or newtons. Remember that forces directed into the circle are positive, and forces directed out of the circle are negative. Possible contributors of centripetal force can be friction, tension, and gravitational force. If an object is moving with constant speed, to find the magnitude of the speed in circular motion, use the formula V equals 2 pi r over t. R stands for the radius and t stands for the period. The units of velocity are meters per second. Conversely, if you rewrite the velocity formula, you can solve for the period of circular motion by using the formula t equals 2 pi r over v. So the last thing for today, acceleration of circular motion. To find the magnitude of centripetal acceleration, use the formula a equals v squared over r, and the units for acceleration are meters per second squared, because the units for acceleration are always meters per second squared.